Hi, in Fundamentals of Wireless Communication, today we are going to see about improving coverage and capacity in cellular network. In improving capacity in cellular systems, three methods are used. The first one is cell splitting. In this, the congested cell is subdivided into smaller cells. The second one is sectoring. The sectoring uses directional antennas to control the interference and frequency reuse. The third one is coverage zone, distributing the coverage of a cell and extends the cell boundary to hard to reach place. Cell splitting. In the cell splitting, the congested cells are splitted into smaller cells, which preserves frequency reuse plan and reduce transmission powers. The cell is splitted into smaller cells. The smaller cells are known as microcell. A cell R is reduced to R by 2 in this cell splitting concept. This figure illustrates a cell splitting within a 3 km by 3 km square. In cell splitting, the transmission power reduction happens. Examining the receiving power at the new and old cell boundary is given by Pt2 equal to Pt1 divided by 16. T1 is the first transmitter and T2 is the second transmitter. If we take n equal to 4 and set the received power equal to each other in this concept, the transmit power must be reduced by 12 dB in order to fill in the original coverage area. The problem is if only part of the cells are splitted, different cell size will exist simultaneously, and handoff issues occurs due to high speed and low speed traffic can be simultaneously accommodated in the cell splitting concept. Activity. What are the next three numbers in this given series? Next, sectoring. Sectoring is used to decrease the co-channel interference and keep cell radius R unchanged. Replacing single omnidirectional antenna by several directional antennas is used in the sectoring concept. The directional antennas radiating within a specified sector. The figure shows the 3-cell sector and 6-cell sectoring by sectoring the given cell into 60 degree and 120 degree. Using sectoring concept, interference can be reduced. Next is microcell zone concept. In this microcell zone concept, antennas are placed at the outer edges of the cell. The cell is divided into 3 different zones in this given diagram, and the antennas are placed at the outer edges of the cell. Any channel may be assigned to any zone by the base station. Mobile is served by the zone with the strongest signal. So in this microcell zone concept, no handoff occurs. The zone which has more power and more strongest signal serves the mobile user by means of zone selector used by the base station. The base station chooses the strongest signal by using zone selector and gives the strongest signal to the mobile user in the 3 different zones. Each transmitter and a receiver in each zone is connected using microwave or fiber optic link to the zone selector and to the base station. No channel reassignment is required, and switch the channel to different zone site is easy in this microcell zone concept. It reduces interference and requires low power. Assessment question. illustrate the cell splitting concept with a suitable example. Today we see about the cell splitting, sectoring and microcell zone concept. Thank you.